finally, I want to give a little spiel about what are some possible dangers of using machine learning in soil science, because as we say before, it's a black box and the interpretation is usually very difficult. And how to interpret it. Even if you are interpreting it, there are sharp values, there are variables of importance. You are just sometimes reconfirming what it does. But having some kind of knowledge guided, hopefully that you can have a more knowledge guided interpretation. And the second one is that there are a lot of proprietary soil prediction at the moment. So various companies come up with various instruments to map soil, to measure soil, and so on. So those proprietary claim that they use AI and so on, but we don't really know what's going on. So if we believe this kind of system, then it could be problematic because there's no transparency of how these predictions being derived. And the third one is that what we call as data science of soil materials. So if we treat as a materials, if we treat it as a data points in machine learning, that means that we can produce all this highly accurate prediction, which has no meaning and which has no use at all. And the next one is that if we keep trusting on machine learning, if we use machine learning for everything, that means that we generally we cannot come up with any new theory because you are just self-confirming of what the data says. And many of the danger is that doing too much with too little, because it's very easy to fit a machine learning model, and then it's very easy to make maps of the world with 100 points, with 200 points, and so on. So, but we have to realize, but most of the time that those maps do not come up with the warning or with the limitations what it's doing. And finally, that if we believe that everything the data is available, that means that we don't go out and collect more data, which is probably not very useful if we keep relying on machine learning. And the next three things is more about AI, which I didn't talk about in this presentation, that now large language model or generative AI is it's being used a lot and it's very useful, but sometimes if we rely on AI too much, then we can have a loss of foundational knowledge. And if we trust AI too much, that means that we could lose our creativity and even have some ethical risks. So finally, this is just my thought of about machine learning and its application. And currently in soil science, I say that some machine learning applications that really needs soil guidance. For example, meta-analysis, which I say that is currently being used a lot. It's easy to generate, it's easy to collect data from literatures. Even now you can use AI to collect the data for you, and then it's easy to put in the machine learning. But I think knowledge guidance about what kind of data is it in it, and that we don't overinterpret, we don't seek what we want to say. I think that is very important. And the second one is in soil mapping, that people want to make a soil 3D mapping. So the tendency that is very easy that you put X, Y, and Z as a covariate, as a predictor, but but we have to know, we don't know about the shape, what is going on, whether the machine learning can really learn about the pattern of the soil. So for example, as I mentioned before, the water retention curve, we can model the water retention curve because we know the shape, we know the physics behind it. But for the soil variation with space and depth, we don't have an idea. So because sometimes it's not monotonic, it can have a bimodal and so on. So trusting put everything to the machine learning, I think it could be a danger. And the next thing is the space-time modeling, because it's so easy to put space and time in the machine learning. People call it a data cube or whatever it is, but does it really model? Can it really model space and time? Because time in soil is a process. So as for example, soil temperature, soil heat, machine learning does not know anything about the heat flow. It does not model the heat flow. So it only models the pattern in the data. Right. So as a summary that for this presentation, I say that soil is a unique 3D volume, and machine learning models should be soil science informed about this about the soil. So we have to design the machine learning application that accommodate the soil, the nature of the soil. So that's why I say that it's soil science informed, that it could be the architecture of the model, it could be the variables that you put in the model, it could be the data layers. It should reflect the unique characteristics of the soil. And the next is that we have to modify the machine learning models to suit our needs, not modify our data to suit what the machine learning needs, right? So most of the time, we have these machine learning models. It can only take one input. It can only take whatever input it is. And we try to force our data into the machine learning model. I think we need to think that now there are machine learning models like neural networks, which are flexible, that you can design, you can characterize. I think it's better to have a more design the machine learning models than try to put your data to the machine learning model needs. And finally, combining machine learning and domain knowledge should provide more meaningful models in soil science. And most of this, what I discussed before, that it's part of a larger review. So if you want to see more examples of how we think that machine learning can be informed by soil science, this is the paper. And thank you very much.